We're gonna get into synthesis today. I'm gonna do a little bit of a review of like last time, just to make sure we're all on the same page here. That is an N2, sorry. I know it was sketchy, but I was like, it'll slide by. Nothing slides by. All right, so for the top one, if I treat that with KMNO4, how many carboxylic acids am I going to make? I'm going to make two, right? Because both benzoic carbons have hydrogens, so they're both going to get oxidized. So what am I going to do for the second one? What am I going to add? Where am I going to add it? First episode of Sesame Street ever. Right, so I'm going to add bromine, and I'm going to add it to this benzoic carbon because it's the only one that has a hydrogen, right? I have to have a hydrogen to remove to replace with a bromine. So the tert butyl group will be unchanged, and I'll put the bromine at that carbon. So what's the last thing going to do? What's the last reaction going to do? We're going to put the Cl from the copper in place of the diazonium. So far, so good? All right. So let's talk about synthesis and then do a whole bunch of synthesis examples that are going to be they're going to be like review slash like learning synthesis all at the same time. All right. So there's some kind of important things to remember with aromatic synthesis, right? First is the order you add groups matters, right? So what I mean by that is oops, that's almost a word. Right, so let's say in your product that the two substituents are para to one another. Well, you need to put on the group that directs para first, right? You need to make sure that you have the right group on to direct in the right position, right? So you always need to be mindful of, well, what order these need to go on so that I'm directing to the right position. Change. You can change. you can change functional groups, right? Because there are some things that we can't directly put on the aromatic ring, right? So if you have an amine, it started out as a nitro group more than likely. If you have a CH2 at the benzoic position, it started out as a ketone, right? So there are a number of things that you have to remember. You have to be able to interconvert one functional group to the other because that's the only way you can get to them. There's no way to like directly put a group on there. Oh, I guess another one is like right. You can turn a CH into an acid with KMNO4. There's no way to kind of directly add. Well, no way that you know to directly add a carboxylic acid to an aromatic ring. You will try on an exam. You will try, but there's no way to do it that you know of. All right, so I had mentioned that there were worked sheets that were online. They are now in the slides. Oh, yeah. This is what I did after dinner last night. So over the next few slides, I've kind of taken the worksheet that you had that was on Moodle and just kind of cut it up so we could kind of work through it. So for the top example here, column number 1, in the product, my two groups are paired to one another. So which group do I want to put on the ring first? Do I put on the tert-butyl group first, or do I want to put on the sulfonic acid first? I want to put on the tert-butyl group first because tert-butyl directs ortho-para, though its ortho positions are blocked. So it just kind of directs para. And the sulfonic acid directs meta. So since I know where they direct, I know that I want the first thing I add to my ring to be my tert-butyl group. Right, so recognizing that they were para, and then knowing which one of those groups directs para, tells you which one has to go on the ring first. So how do I put a tert-butyl group onto a benzene ring? So Friedel-Crafts alkylation. Yeah, so you would just basically take your tert-butyl group, put a chlorine on it or a bromine, right, and then add the correct catalyst. So we can use like AlCl3. How do I add the sulfonic acid? SO3, H2SO4. Right? Now, to kind of like drive home how the order matters, right? This next thing, exactly the same, right? Number 2, right? Is all the same reagents, but I'm just changing the order that I add the reagents in, and that gives you a different product, right? So if I put on the sulfonic acid first, right, that directs meta. So when I add the tert-butyl group, it will end up being meta to the sulfonic acid. So using the same reagents but just changing the order is going to give you a different product. So you always need to be mindful of what order you're adding your reagents in so that you get the right product, you get the right substitution pattern. Reasonable? For numero trace here, which group am I going to put on first? I'm going to put on the bromine because it directs ortho-para. So how do I put on a bromine on a benzene ring? I'm assuming it has something to do with bromine, and then I'm going to add something to it. Not light. Light puts bromines at the benzoic position. FeBr3. So it's going to be great in the light section. They're all mimes, so no one's going to say anything. It's going to be great. We won't even get through the first one. I'll just stare blankly at them, and they'll stare blankly back. They'll be like, I'm trapped in a box. I can't talk. Like, dang it. All right, now how do I add my nitro group? HNO3, and then H2SO4. Now, bromine directs orthopara, right? So, yes, you are probably going to have this other product as well, right? Where you get the ortho product. But in this synthesis that I'm giving you, we're only worried about this one compound. So if you have a situation where you're going to get like a mixture of products, assume that you're just only going to care about the one that the synthesis is asking you to make. All right. So like I think on some of the homework problems that were due on Monday, there was one that was like the actual product that they wanted you to make, and it was like plus undesired isomer. So it was like, hey, I want the para product, but then yeah, I'm also going to make the ortho product, but we don't care about the ortho product right now. So if I'm asking you, if I do a synthesis and it's like, here's this product, just assume that's the only one you care about, and like don't stress yourself out. Like, oh, it could make two. It's like, yeah, but just worry about the one that we need for the synthesis. So another thing you need to be mindful of is the fact that you can go from one type of functional group to another. And oftentimes doing that changes the functional group from being, say, meta-directing to ortho-para-directing. Right, so if I look at my product here, bromine directs ortho-para. My NH2 directs ortho-para for the most part, right? So these are meta to one another. So there's really not a way that I could have had these two groups on there at the same time and got this product, right? Because they both want to direct ortho-para. But you have to think, where do NH2s come from? They come from NO2s. So we can assume that along the way, my NH2 was an NO2, right? Now that you have that, you can see like, okay, NO2 directs meta, bromine directs ortho-para. Which one do I want to put on my ring first since I have my group's meta? NO2. Great, and then we know how to do this. And then how do I turn an NO2 into an NH2? HCl is part of it, and something else. It's a metal, not palladium and carbon. This is like the zinc, tin, or iron in HCl. The other way you can do this react to turn a nitro into an NH2 is H2 palladium over carbon. This way is probably better for this reaction for reasons you don't understand yet. See a nice review of every reaction you've learned. or every reaction that I tell myself you've learned, which I think are two different things. Every reaction I've exposed you to, exactly. So far so good. We're warming up, feeling loose. Let's kick it up a notch. Now, since I'm here to help, I'm giving you more blanks in a row than I normally would. But the general rule of thumb for like an exam is you only ever get 3 blanks in a row. It'd be like A, B, C, then I'd give you something. But I'm here to help, and it takes a village and whatnot, so we can work together through this. So I guess this is number 5. In number 5 here, right, we kind of have the same problem that we had in the last one, where both groups I have on the ring direct orthopara, right? We need a ketone because, right, that's the best way to put a CH2 onto your ring is for it to have like been a ketone at an earlier point in its life. So if we take our ethyl group and we have it be an acetophenone, now this is something we can work with, right? So since we're already here, how do I get from that blue structure D to the product? How do I get rid of that ketone? H2 palladium monoCarbonate. What if we ran out? What's the other way to do it? We're all out of hydrogen gas. Make more. The other way to do it is zinc, mercury, amalgam, and HCl. So you mix zinc and mercury together in a paste, and then you add HCl to it. All right, so what should B be? What is the structure that B should be? It should be just the ketone, right? Because we want to when we want to have the group that directs meta on the ring, so that when we add the alkyl group, they end up meta to each other. How am I going to get the ketone on the ring? What is A? I know, thank you. It's a very good question. Very good at my job. Hmm? I'm going to be using acid chloride. So, right, whenever you have a ketone, you just think I take this whole piece that's the ketone, and I just take off the aromatic ring and I put a chloride in its place. Right? And then what do I have to add to that? AlCl3. Yeah. We can also do it with a bromine. We don't want bromine to feel left out. So we have this next one, number 6. Here's where I encourage you to take your wins where you can get them. Right? So you look at this big thing. It's got blanks all the way up to F. But you have the given thing here to this. Only one blank, right? Just do that one. Feel good about yourself. So what is F? HNO3, H2SO4. Right. So, right, sometimes it's just like best to like find the one that's like you think is easy and do that. Feel good about yourself. and then start on the rest of it. You want to add the isopropyl first? We can totally do that. So we can add the isopropyl first. So that would be B, that. Use our same reagent again. All right. Then we can add our ketone. And then we can remove our ketone. Get our product. Now we can actually do this another way. You switch the second, you go like 2, 3, then 1. Yeah, you put the ketone on, remove it, and then add the isopropyl. Right? So that would look like, we'll pick a different color. This is another reason that I only give you like 3 blanks in a row, is the longer you have without like kind of giving like a handhold, the more different ways you can approach the problem. And on like a written exam, if I gave you this and my key was the blue thing and you put the orange thing, they both work. I would give you credit for it. But in a matching multiple choice situation, I am not good enough with Moodle to be like, oh, it's this one or it's this one. So I just gotta make sure that it's one clear thing, right? And then I can add I went back to chlorine this time, just because, right? But you can do either one, right? Either one works. It just depended on, we said add isopropyl first, and we went with that one. But we could have easily done it the orange way as well. And that's kind of what's interesting about organic synthesis is different people can look at the same molecule and come up with different ways to make it, depending on what reactions they want to use and what starting materials they want to start with, things like that. So far, so good? All right. Let's kind of like work our way back from the product. I think that's easiest, right? You can just kind of start taking stuff off and see what you had before, as opposed to just trying to like build it up from effectively nothing, right? So, what do you think the last thing we should put on the ring is? The isopropyl is probably the last thing that should go on, right? Because if you look at what that gives you as your F, right, it just so happens it works out that iodide directs orthopara to itself, right? The carboxylic acid directs meta to itself. So with those two groups on the ring, right, we're going to activate that carbon right there is going to be the most active carbon. And exactly what was just said here. If you put the isopropyl on before you make the carboxylic acid, the only way you know how to make carboxylic acid is to throw KMNO4 at like an alkyl, at a benzoic carbon. And if you have the isopropyl there, you're going to have 2 benzoic carbons and you're going to make 2 acids. So you need to put the carboxylic acid on before you put the isopropyl group on, because you don't have a way that you can put just one acid if you have the isopropyl group. So again, we already know G. We've done it like 3 times already. So what is D? We'll make it a methyl, right? But D would be, we would be installing the carboxylic acid in E. Right, so how do we make a carboxylic acid? I already said it. KMNO4. Again, we get to me having to say the phrase, what would B? Could be just I. So we could make iodobenzene. Or we could make toluene, because both of those groups direct orthopara. So it kind of doesn't matter which one we add first. So if we go blue, if we add the iodide, how do I add an iodide? Again, I'm assuming it has something to do with I2. And then what do I have to add to the I2? HNO3. What if I went orange way? How would I add that methyl group? We were doing so well. We said add a methyl group, but everyone's just like, I'm sleeping now. If I don't make eye contact. All right. So this is the weird Friedel-Crafts alkylation, where we get to just use like methyl chloride, let's say, and AlCO3, right? This is the one where we don't make a carbocation because we can't, but we just pull on the chloride enough that we're able to kind of do effectively like an SN2 reaction on the methyl group. Right, and then we would use the same thing if we were going blue route here. But regardless of the order, we get to the same place eventually. Oakley dokley? This is where I remind you, you have to know all of your reactions. Like only 7 electrophilic aromatic substitution reactions. You have to know all 7. Oh, it's getting longer. Oh man. Oh man, it's happening. So, there's a few different ways that you can approach this, right? I think doing ABC is pretty straightforward. So we can start there. Get those 3 out of the way. Again, feel good about yourself. So it doesn't matter which group we put on first, right? Because they both direct meta, right? So I'm going to say let's put on the ketone. We've already seen how to do this. You're just going to take off the aromatic ring and put a chlorine in its place. right? And then we know how to put on a nitro group. And this is something that's kind of important to like have in your head. I know I talked about this last semester. Like looking at this whole problem could be a little daunting or a lot daunting, right? So you could just ignore the bottom part and just do A, B, and C, right? Get those points, take a deep breath, and then move on to the rest of it, as opposed to looking at the whole thing as one big thing and having a panic attack, right? And like freezing up and being like, oh my God, there's so many blanks. What? Right? It's easier, I think, if you just go like, all right, let me look at three. Now that I've done that, now let me look at the rest of it, right? Or if you look at the first three and you go, crap, I don't know any of this, right? Then just be like, okay, I'm going to look at the next chunk, right? Kind of look at them in pieces and find the stuff that you can do and don't just like panic and be like, well, I can't do any of it. I'm done. I don't know A, B, and C. I just need to move on the next page and take my L. Like, no, look at the next part. You can figure it out. Where does, and like this is kind of, I think, the key to this. How do you know how to make that? I have to have a diazonium salt. So you know that right before this, or somewhere right before this, you're going to have a diazonium salt. So where does the diazonium salt come from? NH2. So knowing, oops, knowing that the nitrile comes from a diazonium salt, that kind of tells you all the other blanks, right? Because you're like, well, that has to be a diazonium salt. Well, where do diazonium salts come from? They come from NH2s. So that fills in all the blanks right away, just by knowing the only way I know how to put a nitrile on an aromatic ring is using a diazonium salt. Now, D is a little tricky, right? D, we're doing two things at once, right? We're removing the ketone and we're turning the nitro group into an NH2. And there's one reagent that does both of these reactions, right? And someone already said it. I told them to like slow their roll, right? It has H2 palladium on carbon, right? H2 palladium on carbon removes a ketone, a benzoic ketone, and makes it a CH2. And it also removes a nitro group and makes it an NH2. So, again, you have to remember reagents are dumb, right? You can't be like, hey, palladium on carbon, I just want you to react with the ketone, ignore the nitro group. And you can't say like, or you can't say like, ignore the ketone, react with my nitro group, right? It's gonna do everything it can possibly do. So you have a reagent that does multiple reactions, reacts with multiple functional groups, is gonna react with all those functional groups it can. It might react with them at different rates, but for the most part, they're just gonna react. So here we can remove both of those functional groups or change both of those functional groups in a single step. All right, so uh, how do we turn our NH2 into a diazonium? NaNO2 H2SO4. And then how do I turn my diazonium into a nitrile? Copper cyanide. So, especially when you only know like one or two ways to like do a reaction or introduce a functional group, when you see that product, right, when you see that functional group in a product, it just kind of steers you down like one path because you're like, well, I only know one way to do this, so I know what my starting material has to be, and I know what that starting material has to be. So like look at your products and kind of think, again, know your reactions and be able to go like, oh, that comes from this. So I know all these other things. And then last one. Oh no, so many letters. Wait till the final and we hit up like double D. Oh yeah. I had a class was like, you can't use all the letters. I was like, watch me. I'm trying to figure out what your second exam. The second exam in organic 2 in the spring last year was like, I think I told you guys it was one problem. Oh no, it was two functional groups and then a giant synthesis problem, and that was the entire test. And I still have that test. It's saved on Moodle. I could just like reassign it. It'd be great. So many things. This is the you're never allowed to forget anything ever section of the class. So, the bottom thing does come from a Diaz autoreaction. There we go. See? Right? Because when you see a cyclohexene, you should think Diaz autoreaction. But let's take our easy win. What is J? What are we adding to get J? How many BRs? 2. Right? Because this isn't bromine in FeBr3. This is bromine that's going to react with the double bond that we have. Yeah, the double bond right here. Organic 1's calling. It says never forget me. I'm not going to worry 100% their stereochemistry, but I don't know which one's going to be up and which one's going to be down. I just know they're going to be on opposite sides. So if you drew the other diastereomer where you switched which bromine was a wedge and which one was a dash, perfectly fine. As someone pointed out, right, the given product here at the end with the 6-membered ring, the cyclohexene, that's going to come from a Diaz autoreaction. So, right, we can kind of undo this ring. These electrons can come here. These electrons can go there. These electrons can go here. So we're going to end up with doop, doop. Our dienophile, right? And then my methoxy group and my methyl group in the product, they're on opposite sides, right? So on the diene, they need to be on opposite sides, right? So that means one needs to be outside and one needs to be inside. So how can I put this ketone on the ring? Just the acid chloride, right? Okay. So we have our given compound here that has the ethoxy ortho to an isobutyl, right? But we got there by using sodium ethoxide. What's the only thing that we've done that you would have like sodium ethoxide reacting with an aromatic ring somehow? Nucleophilic aromatic substitution, right? So what if you had that? And you add sodium ethoxide, and it will replace the chlorine. And then we could remove our ketone. So like the big hint here is remembering what sodium ethoxide, what reactions we've used sodium ethoxide in with an aromatic ring or something similar to it. So which thing do I put on first? Do I put on the chlorine first or do I put on the ketone first? Chlorine goes on first.
So the question was, why should I put the chlorine on first and not the ketone?
Chlorine directs ortho-para, ketone directs meta. And we put on our ketone. And there you go. We got done right at the end of class too. We did it.